Okay, let's go into the next topic where I'm going to be talking about, compressors and limiters. Compressors, limiters, okay. All right, we always hear that, okay. We always go into our DWs, we have all these different plugins, compressors and limiters. What are compressors and limiters anyway? Now, the name actually already kind of tells you what the function is. These are special devices that reduce dynamic range, okay? When we talk about properties of sound, so I explain what dynamic range is. So the dynamic range here would be the difference between the loudest and softest sounds. So that's the technical definition of what a compressor or limiter is. The common uses of compressors and limiters include: number one, controlling the maximum level of audio. So you want to control the maximum peaks. Here you were talking about peaks. And why is this important? Now, this is important especially, let's say, older days or maybe in a live sound, live PA. If you have very loud peaks of sound, you can run the risk of blowing a tweeter. You can run the risk of overloading some piece of equipment. But most likely, right, in the old days of PA systems especially, we're very worried about blowing tweeter, okay? You blow a tweeter and then suddenly after that, your live show is like, no highs already, okay? It's all bass and mid frequency. So you want to control the maximum level of audio. Okay, number two, right. Same thing, you want to increase the apparent loudness. Firstly, point one is you're already controlling the maximum level, right, the peak level. But at the same time, you also want to make things sound louder, okay? Because again, as we said, louder is better. Wow, okay, right? Louder sounds better, right? So you want to make things seem to be a little bit louder because, again, it has more impact, right? Something is a bit more louder, has a bit more impact, right, to the listener. So number three, it can improve intelligibility. So intelligibility here refers to spoken voice. So it can either be spoken or it can be sung. Going back to, right, controlling the dynamic range. So sometimes if, when a human person talks, when somebody is giving a speech is very dynamic, and sometimes, speakers, very good speakers, they will use dynamic range for sometimes for dramatic effect, or they want to get a point through. So, we have someone who will talk very softly, very calmly. Hey, they will talk about this. So I'm going to be talking about compressors today. And compressors are very important. All right, then, for example, okay, right, a speaker, right, a public speaker who will use all these kind of dynamics because they want to maybe emphasize a point, or they want to, again, for dramatic effect. Maybe some politicians are very good at that, okay? But when you're talking about going to a mic and to a PA system, if you're listening to me like that, you can hear me clearly. But sometimes in a PA system, in a hall, if there's too much variation on the dynamic range, sometimes when you're talking too soft, then you cannot hear. So sometimes if in a PA system inside a mall where it's very noisy, okay, if you talk too soft, right, yes, you are trying to maybe do some dramatic effect or something like that. But if it's too soft, then you don't have intelligibility. You cannot hear what the MC is saying. You cannot hear what the announcer or sometimes the one which is very annoying are usually the VIP the guests of honor, because they don't have the proper mic technique, right? Then they go out, they want to give their speech, their ucapan, they're like, it's like very super boring. Sometimes if you want to help, give a little bit boost, right, to improve the intelligibility, right, compressor will help, okay? A compressor can also be used for tone and coloration, right? Some compressors can affect the tone, right, and can also give a bit of coloration to the sound as well. So what are the main controls and parameters? So let's look at this graph, okay? Let's try and understand this graph. On your x-axis, you have your input level, right? What's the level of the signal that's going into your device? And then you have your output level. So the two values that you want to see here are your threshold. So this is the line where the input level meets the output level, okay? And then you have your gain reduction. So gain reduction, how much compression is being applied? Let's talk about threshold first. What is this threshold? So the threshold is the vertical line. So the threshold control sets the level at which the compression will take place. That's where it will start to compress lah. Only when the signal, right, in the input, only when it passes the threshold will it be compressed. Number 2, the knee, okay, the knee, okay, right, the lutut. So knee here refers to 2 types of knee. You have a hard knee, which gives you this kind of shape. If you can see the wherever the threshold passes, you have a very, very hard angle to it. Or a soft knee response. There are also some compressors which have like a combination of the two, like in between, okay? Like DBX has the over easy. Some of the LA2A, the tube optical compressors have a kind of a hybrid blend between the two as well. Soft knee settings, right? You look at the shape also, you already know lah, okay? Right, they are smoother, a little more gentler than, let's say, a hard knee setting. So when to use a hard, when to use a soft, that is, okay, that's something that you have to decide and use based on experience, depending on what you want. The third parameter is attack time. So we always see, right, compressor, you have your attack, release, threshold, all these kind of words. What is attack time? There's actually a very technical explanation. I won't go into it, okay? But basically, it refers to the time taken for the signal to become compressed, right? After you exceed the threshold. So remember, first of all, you need to exceed the threshold, then you need the compressor to react. So the attack time is how fast it reacts. Faster attack times are between 200 to 800 microseconds. This is microseconds, okay? Not milliseconds, okay? So milliseconds is 1/1000th of a second. Microsecond, right, is like a 10,000th of a second. So slower attack times are between 10 to 100 milliseconds lah. So it can also be expressed as slopes in dB per second, 12 dB per second, okay? But I think we usually refer to the time lah. We usually use milliseconds or microseconds to describe attack time. That's easier to understand, you see. Fast attack times, okay, can actually create distortion. You can actually create distortion. You can actually hear audible distortion one. Because what happens is it actually modifies the signal of slow moving, low frequency waveforms. So especially let's say bass, right? Bass frequencies, low frequencies from a kick drum or bass guitar or some kind of a bass synth or something like that. The waveforms, right, they move a little bit slower, okay? And you see the waveforms are a lot bigger and they're a little bit slower. You see high frequency waveforms, you see they're always very, very sharp. Low frequency is like usually a big, long curve. So if your attack time is fast, right, what happens is that sometimes you actually cut off the wavelength, all right, of the waveform of the bass frequency, and it causes a bit of distortion. So there can be something cool. It can be a cool sound, all right? It can be something that you want lah. Release time. Okay, so release time is the next parameter. So this is technically, all right, roughly it means the opposite of the attack time. So it refers to the time for the signal to go from a compressed state back to the original non-compressed levels, right? So it's basically the amount of time it takes for the compressor to let it go lah, to release it back to its original state. Okay, so you have also you have fast and slow attack times. You also have fast and slow release times. So fast release times can be between 40 to 60 milliseconds. Slow release times can be even slower, can be up to a couple of seconds long, 2 to 5 seconds. Same also can be expressed in slopes in dB, but again, we usually refer to it as time lah. Generally, your release times, most people will find it tricky to set release times and all that because it's very confusing, you see, and you have to hear how it reacts and how the compressor works. And we might not really have time to actually cover, but again, when we are mixing later, you may be able to hear and see what happens. Compression alone, again, can be a whole different workshop on its own, okay? Can be a whole full day topic. Generally, as a rule of thumb, you want to set this as fast as possible to avoid what we call pumping and breathing. Pumping and breathing here means it refers to, you can hear the volume of the sound. It suddenly grows, it pumps up and down unnaturally. So you want to avoid that. You want to do all the above. You want to control your maximum level. You want to increase your apparent loudness. You want to You want to do all the sort of things, but you don't want it to, you generally don't want it to start, all right, pumping. That sounds a little bit unnatural. Compression ratio. Okay, this is the next parameter, the fifth one. Okay, so back again, let's look at this diagram, which will help you to explain what the ratio is. So same thing, right? Input and output level, all right? In the graph, you have your threshold again. So let's say this, in this case, your threshold is 20 dB. So let's look at the first one, okay? The amount of attenuation applied to the signal. So 1-to-1 ratio is unity gain. That means there's no attenuation, right? No attenuation, there's no compression. So look at the first line, the straight diagonal line that goes 1-to-1. Means that your input level is 20, your output level is 20. Okay, there's no compression taking place. That's what we mean by a 1-to-1 ratio. Okay, so what happens if it's 2-to-1? So 2-to-1 ratio indicates that the signal exceeding the threshold by 2 dB will be reduced to 1 dB. So basically what it means is that if your signal level goes to 30 dB, you get an increase of 10 dB, right? So the threshold is 20, you exceed the threshold by 10 dB. But how much compression do you get? How much is it reduced by? Answer? Remember, 2-to-1 ratio. So it's exceeded by 10 dB, but how much compression will be applied in a 2-to-1 ratio? Sorry? 5. Jack got the right answer, 5 dB. So in the 2-to-1 ratio, if the signal exceeds your threshold by 10 dB, your output, your result in the output is, right, 5 dB louder, which means 25 dB lah. You do your maths lah. Mathematically, that's how it's expressed. What if we use a higher ratio then? Or for example, 8 dB, if it exceeds by 8 dB, it gets reduced by 4 lah. So obviously, if it's greater, 4-to-1, it's a little bit more aggressive, 8-to-1, and then, you know, when you get infinity to 1, you end up, it basically becomes limiting. Next part, still talking about ratio. So 3-to-4, 3-to-1, 4-to-1 is considered like medium. 6-to-8 is kind of considered strong. There's no fixed saying fixed value or something like that. It's just roughly only. Now if you go to like 10-to-1 or more, 20-to-1 or infinity, it's basically what we call limiting. So limiting here, it's basically, it's a hard limit. It's like, nope, you cannot exceed. There's no way of exceeding that level already. So that's what a limiting is. Next parameter, we clear on ratio, first of all. You guys, you want me to like explain ratio again? So for example, let me give you, let's say, another example. Let's say, let's just take a number. Let's say, right, 10. Let's start with 10 dB. So if it's 10 dB and then the inputs, your threshold is 10 dB, but your input signal is, let's say, 20 dB. And then you set a 4-to-1 ratio. So what's your output going to be like? 4-to-1, you see? So you exceed by 10, so you divide by 4, 12.5. The gain reduction, right, the output level will be 2.5 dB higher than your threshold. So it's 12.5. Okay? So 8.1 will be a little bit more aggressive. 8.1 will give you the 10 divided by 8. Okay, the maths is a bit harder there. Okay? Right, so we give you 11 point something lah. So obviously, you know, 8-to-1 is going to be a lot more aggressive. Boop, your output level is only going to be 11 point something, you see. Compared to, let's say, if it's a 2-to-1, you get 15 dB, right? So it's much more gentle. So this is where ratio comes into play. So your output gain, or sometimes it's referred to as your makeup gain. Compression attenuates, so it always brings down the level. So make-up gain, right, is applied so you bring the level to the same as the original. So this is very important because compression will always bring the level down. So you always need to bring the gain output, adjust it back up again so that it will be back to the similar and same level. So it will be at the same level, similar level, but the signal is compressed, much more even. The dynamic range is a lot more controlled. Now let's go to the types of compressors. So there are going to be 4 common types of compressors. Okay, there are some other subgroups as well, which you can always read up on. But the 4 common ones that you're going to be encountering. It's important to know because they have their own characteristics. They are suitable on certain things, what you can use. So number one, the first one would be tube compressors. Tube compressors, generally, they will always have because based on tubes, you see, they will have generally the slowest response. They have slow attack and they have slow release times, okay? For example, you have very mu, the variable mu. Mu is the Greek alphabet, the mu, okay? So they use a vacuum tube for the gain control. Famous ones would be a Fairchild 6 Fairchild compressor, right? Manly also has the very mu. This is what a Fairchild compressor looks like. How much does it cost? It can cost as much as a car, okay? Right, these are very rare and highly sought after ones. Of course, there are now, obviously there are cheaper ones as well, okay? But the classic tube compressors like these are very expensive units. It can be like 10,000 US dollars. So next one, optical compressors. Optical compressor, it's very unique. It's very fascinating, you know, how the engineers came up, right, who were building these kind of devices, thought of this idea. Who would have thought the idea that you use a light element, basically a light bulb, and an optical cell to affect the dynamics. You see, especially in the old days, if you use those light bulb, the incandescent light bulbs, you press on a switch, right? It's not instant, right? It takes a bit of time to glow, and to maximum brightness. Same thing when you shut it off, right? You know, the thing is still glowing for a fraction of a second before it goes off. So they actually take use and advantage of the behavior of these optical cells, light bulbs, to affect the gain reduction, the dynamics of a compressor, right? Of an optical compressor. Somehow this kind of curve, right? When you switch on the light bulb and then the light switch off, that curve that results is very musical to us. So it's amazing, man, how these engineers figured this out. As the amplitude or the level increases, the light bulb basically shines brighter. Then it shines it brighter, then the optical cell, right, in response to it, will bring the level down a little bit more. It responds to the input level. So an example of this is the Teletronics LA2A, okay? So this one, also very expensive, but not as expensive as a car lah. I think this one now, the reissue costs about 18K, 1,000 ringgit. So still very expensive lah, okay? So obviously they are clones as well, right? But the actual reissue by Universal Audio is cost about that. That was actually when we did recording last week, we were using the LE610. So that actually, the compressor circuit is actually the compressor circuit from the LE2A, right? It uses the same, it's the T4 optical cell. So these are optical compressors, right? Or opto. Sometimes you hear the word opto compressor, short for optical. Okay, let's go on. FET, FET, short for field effect transistor compressors. All right, as the name implies, right, it is using a transistor, right? It's using a transistor circuit to emulate the compression. So obviously, this is a solid state device lah. Now, some of these can be a hybrid as well. You can have a FET transistor, but you have, let's say, maybe a tube output section, for example. They just use the tube as a coloration. Okay, so generally, FET compressors are fast, they are clean, and they're reliable, right? So a good example would be the 1176, right? LN, okay, limiting amplifier. This is how it looks like. This is the 1176. Now, another type of compressor would be the voltage control amplifier, VCA. What this uses is it uses solid state and also integrated circuits. These are usually a bit cheaper to manufacture, has slightly less coloration. Again, if they are solid state, if they're using ICs, usually these are a lot cleaner, right? So sometimes you want something clean, sometimes you want something a little bit more color. So good example would be the DBX 160, okay? All right, I think we have a DBX 160 inside, but inside is a 160A. It's a slightly different version. This is like the old DBX 160. Now, there are sometimes other types of compressors as well, besides the four general types that I talk about. First one would be a multiband compressor. So what's a multiband compressor? Very easy. Right, it will divide it divides the audio signal into several different frequency bands. So for example, you can have 3, maybe 4, sometimes 5 or 6 or more. And each of these frequency bands will have the individual parameter control. Your threshold, your ratio, everything can be very powerful. You can only just, let's say, affect only the lows, the low frequencies if you want to. You can dial it in so only the sub frequencies, everything below 100 Hertz gets compressed. Can be very, very powerful. This is an example. This is the Waves, the C4 multiband. They call it multiband parametry because you can control all the parameters. Other types of compressors. Okay, so now this one is a little more recent. This is called the dynamic EQ. What is a dynamic EQ? Now, this is actually a combination of an EQ and a multiband compressor. And dynamic EQ is going to be one of my favorites. It's one of the favorite things for me to use. So this allows your EQ to only be applied only when the threshold is exceeded. So it's a combination. So it's not like an EQ where, every time if you boost or you cut, right, permanently that cut is there all the time. Only when the particular range of frequencies exceeds the threshold, then only the EQ will act. Why is it so powerful is because if sometimes let's say you use a traditional normal EQ or parametric EQ, whenever you cut, okay, you listen to something, oh, okay, something needs to be cut. Maybe some frequency rings at a certain time, but not all the way throughout the song, throughout the track. Only certain times only you have it. If you have a traditional EQ, you cut that frequency, it affects everything. So even when you don't need the cut, right, it's already cutting. So sometimes it means that you are kind of affecting the original tone. Maybe you're making it sound a little bit thin, or a little bit hollow. So that's where a dynamic EQ is very, very powerful. So only when it needs to act, only when it needs to boost or cut that frequency, then only it will engage. When it doesn't, it lets it go, it lets it be transparent back to its original signal as well. So dynamic EQs are very powerful. It's one of my favorite things to use nowadays. Okay, and a good example will be this one. This is called the TDR Nova. Okay, so I'll show you later on. Okay, moving on. Other types of compressors. Okay, very one common one that we will always be using is called the de-esser. You know what a de-esser is? Especially when we're talking with a lot of S. Okay, right? A de-esser, right, is actually similar to a dynamic EQ. It's actually similar to a multiband. You can take a dynamic EQ, you can take a multiband compressor also. Let's say you take the same C4 multiband, but you just narrow the band to just towards the frequency where all these S's happen, all the sibilants we call it, okay? So it's similar, but working in a much narrower frequency range. So usually these can either work in a wide band or they can work in a split mode, right? For example, this is again another typical compressor called the Renaissance de-esser by Waves. This is actually the old interface. Now the newer interface looks a little bit different already. But that one you have to upgrade. You have to update one. You have to pay the license. So cool. Those are the most a brief overview of the different types of compressors. Okay, what the parameters, what the controls are. Okay, and also some additional special types of compressors that we're going to use lah. We're going to move on to one more, last one. I'm going to be talking about effects, right? Especially time-based effects. Most effects are actually time-based. Okay. So I'll see you guys in the next segment, right after this short break.